Ankur, you recently published a new piece on your newsletter, and there is a link in the show notes to it, where you talk about the products to expect with the release of ChatGPT. I'd love us to dive deeper into this subject, but before we do, let's first talk about how is ChatGPT different from the previous generations of the large language models developed by OpenAI, and what does it mean in terms of its capabilities?
I think that's a great question. So I think there are two things that are different about ChatGPT and explain why it's been so remarkable in terms of just user adoption, right? 100 million users in just a few months, the fastest growing consumer app of all time. Um, so, two things. One, it's a much better large language model than its predecessors. And it uses this optimization technique called reinforcement learning based on human feedback, so RLHF. You will start seeing that acronym much more often, even among mainstream reporters, because this optimization technique is what made ChatGPT remarkable in terms of human like responses. Um, Da Vinci, the predecessor product, the large language model that OpenAI had, is still very good, but ChatGPT is a level better than that. So I think that was one major difference. The optimization technique led to better results in terms of output. But the second thing, and I think this is the more important long term, is ChatGPT has a true conversational user interface. So now all of a sudden, GPT-3 is not some technical tool or technical technology for niche AI researchers. It is basically a search engine where you could ask ChatGPT open-ended questions in any domain and get pretty good responses back. And it's also one of the reasons why ChatGPT is now referred to as the Google search killer, right? Because this is now a different way of asking a question and not getting URLs back where you still have to search for the answer. You're actually getting the exact answer in response to your question, which is magical when you first use it.
Yeah, the conversational user interface is definitely a huge deal. Even for me, I spent quite a bit of time playing with the previous generations, and you can make them do what you want, but it's way, way harder than with ChatGPT. For example, you need to sometimes offer a series of prompts and like questions and responses in the prompt before you get to your question and then the answer. And you don't need to do that with ChatGPT, it seems. Almost always understands the intent. So I'm curious if this is the result of that reinforcement learning from human feedback, or if we can unpack it a little bit more, how does it work and why it's so important?
Right. So ChatGPT is really good at understanding intent. You're absolutely right. I think with the predecessor like Da Vinci, so OpenAI's GPT-3, you needed to have really good prompt engineering. You needed to phrase certain intent very clearly for the model then to understand what it is that you're asking, and they would give you a response back. With RLHF, what's happened is that humans, a lot of humans actually, provided feedback as to what the optimal response was to a given question that was provided by a human. So, a human would ask a question, the model would have a series of responses, and then human operators would basically rank them, judge them based on how good the response was. And the ones that did a better job of understanding the user intent, they were rewarded with more points. And so over time, the model then learns to understand user intent really, really well. So it's set up to do question answering in a way that was um, remarkable, right? Like it had been super fine tuned on that, optimized for that, at understanding human intent. And therefore, when we ask questions of ChatGPT, it's really, really good at understanding intent, much better than its predecessors. And that's why the response back is super magical, because even if you didn't phrase the question perfectly, it still gets pretty close to understanding what you're asking for and then gives you the response back.
How do you assess or how do you rate the toxicity of the model, or I would say the lack of it, and the efforts of OpenAI to make it more or less aligned.
OpenAI, I think, has done the best job of any large player in removing bias from the model outputs. I think part of it is I think they realize that failures from, let's say, Meta and Microsoft in the past, for example, just to name the two big giants there, in having AI that then was used in biased ways, right? So there, you had biased responses that were um, basically insensitive to particular groups, and therefore they became laughing stock of the internet, right? And I think OpenAI really wanted to avoid that. So every single time it's released a model, it's done it in stages where it understood where the model could potentially get off track and become biased in a way that is insensitive, and it created guardrails. So ChatGPT will avoid talking about certain topics. It will also kind of gear the conversation back to something that it actually knows something about or can opine on. And I think that makes it a much more user friendly experience. You're not going to get garbage responses that are super biased. Um, and I think OpenAI does this really, really well. I think other players that enter the ring in the large language model race will, should take the best practices. Now, OpenAI has a history of doing this. Last 4 or 5 years of doing this. So I think it has a kind of a leg up against the competitors and making sure that there is a good kind of delivery of the model in stages. But it's done a really good job with this.
Okay, let's turn to products now. Talk about some of the products you cover in your piece, and also talk about the guiding principles that helped you think about what kind of products can be enabled by ChatGPT.
Yeah, so I think the thing I said earlier, where ChatGPT was magical because it had such a good user interface. We use that as the lens to think about, okay, if you have a really good user interface to access a large language model, so essentially getting really high quality human like responses back on any domain, what domains could it disrupt? And for us, the edtech domains are the perfect domain for a conversational UI. So obviously, we know this education is super important, but there are not enough really qualified teachers to deliver personalized education to every single student out there. Um, this is true of any country, right? Class sizes, the ratios, they've gone from like 10 to 1, like maybe in previous decades, to now 20 to 1, 30 to 1, which means that there's one educator for 30 students. And that means we're moving to less quality education per student. So AI tutors are going to become a big thing because now all of a sudden you can ask personalized questions and the AI will give you really good responses, drawing on the best knowledge it can from the public web, and then also for specific domains. So you could have tutors, let's say for MCATs, for SATs, for like your bar exam, as well as like any subject that you care about, whether it's American history or creative writing or physics. So AI tutors are a huge one. But then the other one is something that we're more familiar with, which is Google, right? We use Google search all the time, or Bing, or DuckDuckGo. And what it does, it gives you back URLs with basically sites that provide an answer to a question that you may have. But I think what ChatGPT does is it gives you the precise answer back. So it's a much more opinionated response to your question. And so it feels like you're conversing with a real human. You almost lose uh, that feeling of like, oh, you're just interacting with the machine, because it feels like a human is on the other end operating a response back.
That's very true. I did try to use ChatGPT in a use case where Google actually failed me. And ChatGPT did deliver the proper answer. And when I say failed, I mean it did return me the set of results, but I browsed through first 10 or something. I didn't find the right answer, the answer at least I was
Mm-hmm.
expecting. And then I used ChatGPT and then did produce it, which was remarkable. And the question, though, for the search engines, I think is that ChatGPT is quite heavy in terms of your resource consumption, and how can you run it at scale. On the other hand, I just read this morning that Microsoft is rumored to incorporate ChatGPT into Bing almost in the next few days or something, or few weeks for sure. What's your take on it?
I think that this type of technology, like ChatGPT, a conversational UI, can be a step function change in search engines, right? Because I think search engines were really good at giving you at least some URLs, some websites back. But if you could avoid having to go and traverse that website and get a really great response back, why wouldn't you choose that? I think the challenge with ChatGPT is that it's traded on public web data. But let's say there's certain domains that you really trust, like WebMD or the Mayo Clinic for healthcare related questions. If you could select those resources and then ask a question and then have the AI basically peruse, like learn from those websites as like the domain knowledge, um, or the domain of knowledge to draw upon, then all of a sudden you're getting the Mayo Clinic and WebMD and a couple other resources response back to any symptoms you may have. Why wouldn't you query that versus having to find through the web pages of all these sites and then figure out what the right response should be? So I think you will start seeing this. I think it's a game changer. I think Google should be scared of losing market share in search, which sounds crazy to say because they've had a near monopoly for so long. But if Bing incorporates this, I think they will take a lot of market share if they have the right user experience. But that's just a starting point. Microsoft, because of its partnership with OpenAI, can basically introduce this to their entire suite of Office products, including their inbox to generate marketing copy or sales copy, or respond to business emails. Certainly draft all sorts of memos and proposals and presentations on Word and PowerPoint. I mean, this is a dramatic productivity boost to the everyday white collar office work.
And you also talk about many other products in your piece. You talk about AI assistant, you talk about automated project management, you talk about alert tools. I encourage everyone to check out the actual piece for the deep dive into the rest of the products. But here I'd like to focus on some of the things, and I think this is going to be a segue into the question of the limitations of ChatGPT, is to double click on that search engine inside the medical database or even the educational use case that you mentioned. Both of them need the AI system to make sure that it delivers correct answers to
Mm-hmm.
the user. So that seems to be still and not fully solved problem for the large language models. How do you see that? And also, what other important challenges of ChatGPT that we will need to overcome to expand it to other use cases?
So I think the optimization technique that was used, so RLHF, which has come up a few times now in this conversation, can be specifically oriented to a domain. So if it's healthcare, for example, I could imagine a ChatGPT version for just healthcare, um, almost like a teledoc, but the RLHF component, so the human feedback component, is being done by trained professionals, right? So they see a series of questions from humans, from human users asking of everyday medical questions, and then they basically, the medical professionals, they rate the responses that the model generates, and then over time you have something that is more peer reviewed, or professional medical professional reviewed responses back. And I think that is an area that you can potentially see for many domains. So the specialists in a particular domain provide human feedback to the model responses. The models basically fine tune our particular corpuses that are deemed to be credible, and trustworthy. And then you could start building versions of this where the information you're getting back from the model has been vetted. The problem with ChatGPT, the big limitation there, is that it's been trained on such wide variety of public web data that sometimes the response that you get back may not be the right response or the appropriate response. And I think that is the scary thing. People are turning to it as a therapist, as a medical professional, and these answers aren't vetted. And sometimes they could be wrong, even though they're opinionated responses. And so I don't think you should trust the responses entirely, right? You should still be skeptical because these haven't been reviewed by experts in that domain that you're asking about, particularly if it is involving like healthcare or medical advice.
And the way I think about the current state is that it's a great drafter. It can provide you with a great draft of something, of a language piece, of a computer code piece, of picture if we're talking about like multi-model models. But it's you can use it as a definitive tool where the set of answers is limited, the closed-ended systems. And when it's open-ended, you'd better review the end result before you actually using it. That was a interesting article recently about how CNews, I believe, started using the large language models to draft articles. And then they discovered that more than half of them had mistakes that slipped through the cracks of editors because editors became too dependent or too trustful to the results of the large language models. So it's really hard to keep that vigilance when dealing with the results that are almost always perfect.
That's exactly right. That's exactly right. I think the human operator can't fall asleep at the wheel, and I think that's a scary thing. I think the other thing to be careful about, and this is an open challenge for ChatGPT, is there is not always one right answer to a particular question. Um, so here's like a good example in the world of investments. Um, what is an optimal portfolio allocation? If you ask 10 experts that, particularly if they're 10 experts that have different backgrounds at different funds, they will give you 10 different answers, right? And all of them could be reasonable answers for the right individual or right family office or right institution. But knowing like what preconditions are necessary for that advice to actually be the right advice for that particular entity or person, that's going to be difficult for a chat GPT to figure out because it'll give you one of the experts' responses, but it may not be really fine-tuned and personalized to the extent that we need it to be. Um, and I think that's an open challenge. Like, how do you actually take the user's circumstances into account when you give them the right response back?
Right. And when you think about those more narrow cases, it seems like it's going to be so hard to develop one language model that can cover all of them and be great at legal advice and great at financial advice and so on. So let's zoom out and talk about the large language models landscape, the players there, and how do you see it currently, and specifically the open source versus commercial field.
Yeah, so the large language model landscape is now pretty rich. So I think everyone knows like Da Vinci, so OpenAI GPT-3, their largest variant. It has 175 plus billion parameters. Um, so that's very large. This is measured in billions of parameters. The open source variants like GPT-J has 6 billion. So 6 billion versus 175 billion. And then Neo X has 20 billion parameters. So the two open source, J and NeoX, they have 6 and 20 billion. OpenAI has 175 billion. And then you have like NVIDIA's Megatron, which is basically half a trillion parameters, half a trillion parameters, so over 500 billion parameters. And so the larger the language model, the more capable it is, but the more expensive it is to actually run inference with. And frankly, to even train it with those many parameters, you need a lot of resources. So hundreds of thousands, if not millions of dollars of compute resources and the time and also the technical knowledge to go into it well. So I think what you will see is a lot of big, well-funded players. OpenAI, of course, is one of them. You have the open source models. other firms like um, Anthropic and AI 21 Labs, NVIDIA certainly, right? So you'll have several players that enter the mix with their own large language models. In some cases, like NVIDIA is actually creating the infrastructure, the platform, where individuals can train language models from scratch. And this is particularly relevant to large institutions that have the budget to train their own large language model. But the rest of us, we will be using a large language model from one of these players, fine tuning it, maybe doing optimization on our own side. And I think this is an area that there could be a lot of potential opportunity. So building like an RLHF platform, so humans can provide feedback to a pre-trained language model to optimize it and then make it relevant for a particular domain like legal or healthcare or finance. Um, but basically, people will not be designing their own pre-trained language models. They'll be working on the optimization and the prompt engineering and the fine tuning. Like that's where I think you'll see a lot more creativity and new startups uh, pop up.
And in terms of the overall development of the models, it seemed to that almost daily, I think a year ago, we heard announcement of bigger and bigger models, and up to 1 trillion, I think, at some point. But then it kind of settled down a little bit, and we don't hear that much about new records there. Do you think it's just the break and it's going to continue in that direction? Or do you think the parameters will become less important?
My personal take is that you will certainly see larger and larger models, but they become unruly because they become really expensive to perform inference with. And then you can't have, for example, edge compute. So you can't run ChatGPT on your phone, like on the device. You'd have to run it in the cloud, right? And so I think you'll see a lot of energy invested into smaller but very performant models. So models that are fine tuned for particular corpuses. So they're lighter weight models with fewer parameters, but they're very good at solving specific domain specific problems. The other big area, and this is where I agree with you, is you will see a lot more optimization methods being used like RLHF. And so with RLHF, you could have a smaller language model, but optimized to perform really well. So it costs less to perform inference with, but has really great performance because it's been optimized using that optimization technique. And RLHF is the most promising of the optimization techniques out there, but there are several others that are being worked through in academia. So there will be more breakthroughs. I think we're just barely scratching the surface right now, but the energy will be more on that as opposed to just building larger and larger models, because larger models, it just means more expensive compute and also takes longer to perform inference with. And I think if we want to get to a world where you could do inference on your phone, for example, on the fly, uh, we would need to get much lighter weight models versus what we have today.
Yeah, this is a very interesting direction of research of how to incorporate all the richness of these large models into the smaller size. And the question is whether we'll be able to do that, or whether the Moore's law will help our compute and storage on the edge devices just catch up to be able to store the thing. It's it's not clear. But what do you think about the architecture itself? So we're currently heavily reliant on transformers to deliver all the large language model breakthroughs. Do you think transformers will be enough to get us to, say, the quality levels we would be comfortable with to trust the models? Or do you think we'll need more breakthroughs there?
I think, I mean, if history is any guide on this, a transformer architecture will eventually get replaced. We don't really know what it will get replaced by, but it's been so dominant since 2017, 2018, right? So about 6 years now, 5, 6 years. I think that it would still is here to stay, but it's hard to imagine that it will be still the dominant one like 10 years from now, 5 to 10 years from now. So I think there will be more innovation on the architecture itself. Um, but it's really hard to say like what will replace it and when. But I do know that the pace and also the funding that we have right now means there's going to be a lot of innovation, not only in academia and research labs, but also in the applied world over the next few years. Um, it does feel a little bit like there's a hype cycle. So, like in terms of funding, right, you're seeing a lot of money rotating out of crypto seemingly into AI, particularly generative AI, which means there's a lot of funding. There's a lot of new projects being lifted off the ground, which means that there could be great innovation, great breakthroughs, but potentially also failures, right? Like you could potentially see the pace slow down at some point. Now, I think we're still early on in the cycle. Um, and I think basically there's so much to go and build, even off of the innovation that we have from, say, ChatGPT. So I'm really bullish on this kind of this industry, at least for the next several years. But you can never bet on just like one technology being the dominant technology for some prolonged period of time. Because especially in AI, we see new architectures basically supersede the previous one, and then the previous ones become obsolete, and then no one uses them anymore, right? We've seen that with RNNs and LSTMs. Like those older models people don't use outside of maybe like time series prediction nowadays.
Right. It does seem like every model finding some of the use cases where it's maybe the perfect way to approach it, but then the mainstream moves on to the next and next, more and more compute hungry architecture because now
Sure.
compute is more and more abundant. In terms of the market structure, I know it's super early days to talk about it, but still curious, what do you think? How do you see that unfold? Will we end up with a, say, operating system or databases market structure where a handful of players takes majority of the market, or will it be different for the AI systems, particularly the large language models?
The ownership of the large language models, just because how expensive it is and the compute intensive nature of it, I think will still be dominated by, let's say, a dozen players or less, right? So OpenAI and others, um, they will own the pre-trained large language models, unless there is a huge consortium like Luther, for example, with the GPTJ and Neo. Um, that releases like open source large language models that compete with the OpenAI variants. But I think you'll see basically a few companies own the large pre-trained language models, um, and I think NVIDIA offering architecture or sorry a platform for people to train their own large language models should help. But I still think that's an arms race that the majority of institutions don't have the time, the bandwidth, or the money to go and work on. But I do think that owning like really domain specific corpus, or like owning the data, that's going to be a big play. Owning platforms that help do RLHF really well, like a really elegant user experience, especially making that available again in different domains. Building fine-tuned language models using RLHF for specific verticals, building really good product wrappers around those. Those fine-tuned language models. I think that's where the innovation is going to be. That's the area where I think startups can still operate, but they're not going to win that arms race with OpenAI. I think the other interesting thing is over time, the language models themselves become commoditized, right? Like you could use a large language model to get started, but then um, the marketing effort to deliver really good user experience for a particular domain, that becomes really important. Um, and I think there's still some big open challenges. I know we haven't talked about this much, but um, these large language models can only generate like 4,000 tokens or so at a time. So it can't really do super open-ended like completion of text. It also struggles with holding memory, so memory of past conversations and bringing in external knowledge and saying like use these resources to go and generate an essay or formulate a proposal for a grant or write a dissertation or give me some medical advice using these resources. It's not capable of doing that, right? And that's partly a technology problem, so better architecture, bigger model, but it's partly also just a product problem, not being able to feed in external knowledge and have it kind of cue in on that. So I think there's going to be a lot of innovation to make that easier and simpler, particularly for product teams to start working.
Right. Definitely lots of things to build around the core large language models. And also a question about where the fine tuning will be happening. So it looks like it's not the fine-tuned model for every industry produced by one OpenAI or whatever. So it's only like a pre-trained draft model that you can use to fine-tune. But then you can either think that every organization will fine-tune it for their needs, or there will be like companies in between that will offer it to the segments or certain industries. What's your take on that?
I think in the short term, it's going to be the latter, where there's going to be an intermediate layer of companies that fine tune and do the optimization for specific domains, right? And then they would cater to, let's say, the legal domain. There'll be a company that caters to all the legal domains to help them complete memos and do discovery and review legal documents. But I think over time, you should see simpler and better user experiences for, let's say, like a big law firm to have their lawyers provide human feedback to what the model generates. And so they're training the model to become really good, particularly in the style of the law firm, right? So that law firm might have a particular way of addressing comments or working on particular negotiation points, and it doesn't want to feed that knowledge to some external player's legal large language model. It wants to own that. That's IP. They're also doing that on their own data. And so they have their own data. They provide their own experts, the lawyers, and they provide their feedback in a easy to use user interface. And then they build core IP for that law firm. So in some ways, every single firm will become an AI firm if they have those needs. Whereas like they have experts, they have their own data, they want to own their IP, and then they just need the right platform to go and do that. Um, and then so then all of a sudden now they're an AI firm. Although that might take another 5 years to play out, but I do think that eventually that's where we'll head.
And speaking of data, we didn't touch it, but the question is right now, it's not exactly clear how IP clean and the large language models are because of scraping the internet. So do you see as a next step the offering by the giants of LLMs, the clean baseline language models that are trained on curated data sets?
It's hard to say. I mean, part of me says that won't happen because it's so hard to prove that certain IP leaked, right? So, like, even in the case of GitHub Copilot, GitHub had access to so much code. It's obviously owned by Microsoft. They have Microsoft's invested in OpenAI, so it could build off Codex. Um, Hard to say like which code it trained on versus didn't, even if there were public versus private repos. Um, and you see a lot of complaints, right? I mean, lawsuits around this, where basically the code originators, the code owners, are saying that the code that's being generated by Copilot is too similar to code that they've written. And it may very well be, but how do you prove that out in legal court to force the big giants to go and develop clean versions, so the IP clean versions? I think that unless there's some major legal action that's taken on this, I doubt the tech giants would move to their own like clean IP models, because there's nothing to prove that they actually trained on data that was private or IP of some other institution, at least so far.
I see. Yeah, this is a very interesting way to think about it. Can you actually kind of trace the model results to the training sets that were used for the training? Okay, sounds good. Look, that's all the questions we wanted to cover here. So thanks a lot. And please check out the actual piece. It's in the show notes. And thanks a lot.
Thanks for having me. Really appreciate the time.